Okay, so here we are in problem number 1. I'm going to rewrite it on a fresh screen here. Okay, so whenever we have these three equations with three letters things, we need to get one letter to drop out of all three. It doesn't matter which letter. It can be X, Y, or Z. So I could use this plus Z here and add it to the negative Z, and that'll drop out, and then separately add it to that one, and it'll drop out. So I'll take equation 1 over here, X minus Y plus Z is negative 9, and equation 2, 3X plus 2Y minus Z is 10. So the reason I pick these is because they're opposites. If I add them up now, what am I going to get? 1x and 3x is 4x. 2y minus 1y is 1y. Make that a little neater there. And these cancel. And 10 minus 9 is 1. Okay. Next, I'm going to take the second equation. No, not the second. The first equation. X minus y plus z. So using the first equation again, and this time I'll put it with the third. So it's the first and the third. That's a minus 2x. So that's a minus, so minus 2x plus 3y minus z is 29. Add them up. So this is, move this out of the way. 1x minus 2x is minus 1x, and then 3y minus 1y is 2y. The z's cancel, and 29 minus 9 is 20. Okay, so I got z to drop out of the first and second equation, and then the first and third. So let me bring this over here. I have two equations now that just have x and y. So I got z to drop out. So now with these two equations, I'm going to get another letter to drop out. Doesn't matter, y or z, I mean x or y. So I'm going to multiply maybe the top equation through by negative 2. What I'm doing is I'm looking at y. If I can make this a negative 2y and add to the positive 2y, that'll zero out. So this will get minus 8x minus 2y is minus 2. That goes boom, boom, boom. And the bottom equation, minus 1x plus 2y is 20. Bring it down. Add those up. Minus 9x. These cancel. 18. Does everybody see that? This equation came down to here, and this came down to there. And now I can solve for x. Divide by minus 9. So x equals minus 2. So we have x. So now, to get the other letters, we plug back in. So you don't want to go all the way back to the beginning where you have x, y, and z, but you just want to go back to one of the equations where you only had x and y. So go back to this one, for example. If I plug in now, plug in x equals negative 2 right there, what am I going to get? Negative 1 times negative 2 plus 2y is 20. What's that? 2 plus 2y is 20. And then subtract 2 from both sides. So what do we get? 2y is 18. And then divide by 2. So y is 9. So we have y, we have x, and now take those back and plug it in like to the first equation. So I'll go to a fresh screen here. So the first equation is x, what is it? X minus y plus z equals negative 9. X is negative 2, y is 9. X is negative 2, y is 9. Okay, so I'm going to plug those both in. So grab that X and put it in. Grab that Y and put it in. What do we get? Negative 2 minus 9 plus Z is negative 9. So minus 2 minus 9 is minus 11. Get Z alone, add 11 to both sides. Z is 2. So there's our answers, X, Y, Z. So negative 2 for X, and then Y, and then Z. Y is 9, Z is minus 2. We got it. Okay, so now we're supposed to graph. So let me grab this first one. I'm going to get Y alone. I'm going to jump the 2X to the other side. Y greater than or equal to negative 2X. So let's graph that one. There's a plus 0 out there. So you start at 0, right in the middle, right in the origin. And then minus 2 over 1 is the rise over run. So you go down 2, 1, 2 over 1. So right there. So down 2 over 1. So it just keeps going down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. I think I'm doing that right. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And you can go the same thing backwards. Over 1, up 2, over 1, up 2, over 1, up 2, oops, etc. Right. So there's the line. All right, so there's that line. And now for the other line, this one, bring it down here. 5x minus 7y less than or equal to 14. This one's a little more tricky. We've got to get y alone. We always have to get y alone. So take this 5x, jump it to the other side. Minus 5x plus 14. Next step is divide through by minus 7. But do you remember what we have to do? When we divide by a negative, remember, we've got to flip that symbol the other way. Symbol has to flip. So we get y greater than or equal to. So let me write a note. When divide by a negative, flip the symbol. 2 negatives here makes positive. Positive over negative makes negative. So now we're ready to graph. Start at negative 2. Get this out of the way here. Start at negative 2. That'd be right there. Negative 2. And the rise over the run, we go up 5. 1, 2, 3, 4, 5. Over 7. 1, 2, 3, 4, 5, 6, 7. Boom, right there. Connect those dots. I didn't do that very straight. There's that line. But now, where's the... Oh, there's one more line, huh? I forgot about the other one. So this one, y is less than or equal to 5. So that just hits the y-axis, right? Because it's y at 5, which is right here. So it just goes straight through the y-axis at a height of 5. Okay, now, we want where the 3 shadings overlap. Let's do them one at a time. So start with the red one. Y is greater. So that's above. That's above the red graph. Let's do the purple one. Purple one. Y is also greater. That's above the purple graph. Greater. And finally, with the green one, y is less. That's below the green graph. So where do all 3 shadings overlap? Above, I think all 3, looks like to me they overlap right in here, because that's below the green graph and above the other 2 graphs. That's where the 3 shadings all exist, right there. There's our answer. Okay, so this is a 3 in the hook, so that means it's a 3 rooter. There's a negative in the front, so that just means the answer is negative. So anyway, what do we do with the 3 rooter? Well, it divides all powers by 3. So that's going to, right, get the idea of what I'm saying by that? So let me write it down here. So if you take z to the 30th over 27x to the third, and we're cube rooting it with a big negative in front, it's going to be negative. And now on the top, so I'm just going to make it two separate. It doesn't matter, top and bottom. Make a big cube root on the top there. So z to the 30th, that's 30 z's. Now, I don't really want to write them all out. 3, 6, yeah, it's too many to write out. If there's 30 z's, and every group of 3 is going to send 1 out. Every group, remember, a 3 in the hook means a 3-for-1 deal. Every 3 z's sends 1 z out, and they're gone, etc. So we're going to have, there's 9, 12, etc. So how many groups of 3? If there's 30, that's 10 groups of 3. So we're going to end up with z to the 10th, right? It divides the 30 by 3. 10 come out. If you have 30 items, how many groups of 3 is that? That's 10 groups of 3. Now on the bottom, what do we have on the bottom? We have the third root of, on the bottom we have 27. 27 is 3 times 9, and 9 is 3 times 3. So we have 3, 3, 3, and we have x, x, x. Again, he's 3 in the hook, so 3 3's in, sends 1 3 out, and they're gone. 3x is in, sends 1 x out, and they're gone. So 3x on the bottom. Negative z to the 10th over 3x. And there's no more roots, because everything left the root. There's nothing left over in the roots, so they vanish. If there was something like a y or something left over, an extra x or whatever, then the root would stay. But if there's nothing left over in the roots, they vanish top and bottom. So number 4, they're saying identify the domain and then graph the function. How do we do that? How do we identify the domain and then graph the function? Well, the domain, whenever you have a root and you have like something inside the root, you grab the inside and you say the inside of a square root. What can you not put in a root? Do you know you cannot put a negative in a root? Because the square root of negative numbers, like the square root of negative 4, that's imaginary. There's no number times itself that equals negative 4. You can't have negative inside of a root, right? What times itself? You can't say, well, the answer is 2. Well, 2 times 2 is not negative 4. You can't say, well, it's negative 2. Negative 2 times negative 2 would be positive 4 if they multiplied, right? It wouldn't be negative 4. So there's no way you can have a negative in a root because you can't square root a negative number. It doesn't equal anything. There's no number it could equal. No number times itself ever goes back to negative. So you can't have negative in a root. And so that's what they mean by domain. When they say domain, they're saying what's allowed. What can you put in? So the inside of a root must be greater than or equal to 0. What does that mean? Not negative, right? Greater than 0 or equal to 0 is not negative. Not negative. So that x must be greater, that inside there, that x must be greater than or equal to 0. You can't put in negative numbers. So the domain, they want interval notation. How do you say that on an interval? Like if you had a graph, here's the x-axis, that would be 0 and everything to the right, greater than or equal to 0. How do you say that? Remember, an interval, you say left edge, right edge. I don't know if you remember, interval is left edge. I've got to say left edge, comma, right edge. And the left edge is 0. The right edge is infinity because it goes forever to the right. And you put a parenthesis next to the infinity. You put a bracket next to the 0. Why? Because you're straight on. Bracket means you've got to straight back to it, straight on 0. And parenthesis means you're just around it. You're close to it. You're not straight on it. So you're never straight on infinity. You're always just going towards infinity. So bracket 0, infinity with a parenthesis. That's the domain. Now, which one of those is the graph? To figure out the graph, probably what I would do is just, I don't know what I would do. Maybe if I get this out of the way, make a little XY table. Probably the best thing. So I'm just going to make a little XY table. And, oh yeah, we learned this earlier, didn't we? We learned that the square root, what does the square root function do? it looks like a firework, right? Usually starting at the origin. What does that plus 2 do? Moves it up 2. Remember how that's an up 2? So it would be graph B here, right? Moved up 2. See how the starting point is up 2? Up at 2? That's what it does. So remember, any number added like that moves a graph up or down. Plus 2 would be up 2. Minus 2 would be down 2. It normally starts at the origin, but numbers added or subtracted off to the right move it up or down. Okay, so x to the minus 1, they say they want positive powers. So what does a negative power do? It makes it flip to the bottom, and then the power becomes positive. So negative powers jump to the other side, and then the power becomes positive. And that's all we do. Negative powers are unhappy where they're at. They want to jump to the other side of the fraction, and then they become positive. Okay, so this next one, what do they want me to do? Well, they want me to simplify this as much as possible. How do we do that? Well, there's a rule that says, here, let's do this. Let's break it into two separate things. Let's take the number separately, and then the u squared separate. So I just put the 3 halves on that guy and on that guy separately. Okay, now with this guy right here, this numbers powers outside parentheses multiply powers inside. So this power inside, this is 2 over 1. So this will be u to the 2 over 1 times 3 over 2. They'll multiply. Remember, they cross cancel, so that's just u cubed. U cubed. So when they multiply, or you could make it 6 over 2, and that's also 3, right? If you just multiplied top and bottom. So that's going to be u cubed. Powers outside parentheses multiply powers inside parentheses. And what happens with 16 to the 3 halves? The 2 comes around into the hook, and it becomes the 2 root of 16, and then the third power is kind of on the outside. What's the 2 root of 16? That's 4 to the third power, and if you take a calculator, 4 to the third power is 64, and then we have the u to the third. So there we go. Okay, so on this one, let me see, I'm going to have to, we have the rule, powers that are side by side, they add, and powers that are up and down subtract. So first off, I'm going to have to add the powers on the top. So I'm going to have to take 3/4 and add 5/8, and then I'm going to have to subtract the one that's on the bottom. Does that make sense? Add the ones on the top, subtract the one that's on the bottom. And what about this negative sign right here? That just means the whole fraction's negative. I think they're trying to trick us there and make us think we have to do something special. That's not a negative in the power zone, so we're not going to jump anything up or down. It's just a negative in the front, so it's just a negative. So I'll just put the negative in the front there. So it's going to be negative b. Now, to add these up, I've got to get a common denominator, which means I multiply top and bottom of that guy by 2. So that'll be what? 6/8 plus 5/8 minus 3/8, which is negative b. 11 minus, is that 8/8? 11 minus 3, yeah. So that's just negative b to the 1, which is just negative b. It's interesting. After all is said and done, it's just negative b. All right, let's try number 3 down here. Or sorry, number 8 down here. It's a cube root. And so you, here, let me go to fresh screen. So number 8, cube root of 108. So I'm going to take the 108 and I'm going to break it down. That's 2 times, what's that, 54. 6 times 9, 2 times 3, 3 times 3. So I broke down the 108. So this becomes cube root of 2 2s and 3 3s. 2 2s, 3 3s, and y to the 7, 3, 4, 5, 6, 7, like that. Okay, and now it's a 3 in the hook, so that means 3 3s in, 1 3 out, they're gone. 3 y's in, so it's a 3 for 1 deal, 3 in, 1 out. 1 y out, 3 more y's in, 1 more y out. So what comes out? 3y squared, okay, and then cube root of, what's left inside? 2 times 2, they couldn't come out because there wasn't 3 of them. 2 times 2 is 4. And what else? And then the y, is left. So there it is, 3y squared, cube root of 4y. Okay, so square root of 4, x squared y to the 8th. So how do we do it? Well, again, I'm going to break it all down. There's nothing in the hook, right? So that means 2 really is there. It's a 2 root. So 4 is 2 times 2. X squared is xx. Y to the 8th is 8y. 3, 4, 5, 6, 7, 8. Okay, so this is a 2 in the hook. So 2 2's in, 1 2 out. 2x is in, 1x out. 2y's in, 1y out. 2y's in, 1y out. 2y's in, 1y out. 2y's in, 1y out. So what makes it out altogether? 2x, how many y's? 1, 2, 3, 4 y's. Is there anything left inside? I guess not. Everything went out, so there's no more root. That's it, 2x y to the 4th. Okay, we want to find the distance between these points. How do we find the distance between 2 points? The formula, here, let me go fresh screen here. So number 10, negative 8, 8, negative 4, 1. Distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. So this is x1, y1, x2, y2. So the distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, and then double negative here is positive. And this is 7 squared, so that's the square root of what? Minus 4 squared plus 49, which is the square root of 16 plus 49. Square root of 65. There we go. Okay, so here we have number 11. Got to break these roots down. This 50 is 5 times 10, 2 times 5. 28 is 4 times 7, 2. 18 is 3 times 6, which is 2 times 3. Okay, so what do we have then? So we have 8, and the root of 50 is 5, 5, 2. So it's 2 times 5, minus 4, square root of 2, 2, 7. So it's 7 times 2 times 2. Minus 5, and the square root of 18 is 2, 3, 3. 2, 3, 3. Okay, so there's nothing in the hooks here, so that means it's a 2 for 1 deal. So 2 5's in, 1 5 out, they're gone. So that's 5 times 8, 40 root 2. The 2's left over inside, minus 2 2's in, 1 2 out, they're gone. 2 times the 4 outside, 8. The 7's left inside. And then the 2 3's in, 1 3 out, they're gone. Multiply on the outside, 15. What's left on the inside? Root 2. So now, can we go any further? Yeah, it turns out we can do one more thing. 40 root 2 and 15 root 2 are like terms. 40 root 2 minus 15 root 2, what's that, 25 root 2. So we have the minus 8 root 7, which stays as it is, plus, what's that, 40 minus 15 is, or you can put it in the front if you want, 25 root 2. It doesn't matter, front or back, whatever. 40 minus 15 is 25, roots of 2. So there's our final answer. So this thing's going to distribute. Root 5, root 5. So what is that? Well, that's root 25 plus, and then x, 5 times 15 is 75. So the insiders multiply the insiders, and then you simplify. The root 25 is 5. And then the 75, you can break that down. That's 3/4, and that's 5 times 5. So those two 5s send out a 5, and 3x is left inside the root. Does that make sense? We had the 3. Oh, no, the x is outside, isn't it? What am I doing? Going too quick. The 5 makes it to the outside with the x, and the 3 is left is the only thing inside, because this 5, these two 5s, send a 5 outside. So it's 5x outside, and the 3 is left inside. We can't simplify that at all. Those are unlike terms. It just has to stay like that. Okay, so we're on number 13. We've got to distribute this, FOIL this out. So this guy's going to go boom and boom. Now, as we go, remember that 36 is 6 times 6, huh? So it already has two 6's inside. So when we multiply this times this, it's going to be third root of the original 6, and then the other two 6's. The one from here and the 2 from there. Okay, so now let's keep going. Minus, and then the third root of 6 goes here, so the 3 just stays on the outside, and the third root of 6 stays where it is. And now the 2 is going to go there and there, plus 2, third root of 36, minus 6, because 2 times negative 3 is negative 6. Okay, well, can we simplify? Yeah, a little bit. These 3 6's in, we'll send 1 6 out. That's just 6. And then the rest of the stuff pretty much stays as it is. Except we can do one more thing now. 6 minus 6, they're just going to cancel, huh? So we have minus 3, third root of 6, plus 3, third root of 36, and that's it. We can't combine those any further. They're different roots, so remember it's unlike terms. They have to be the same roots in order to add or subtract, like they just stay as they are. Okay, so in this one, when you have a root that's over a whole fraction, you put the root on the top and on the bottom, and 45 is 5 times 9. 9 is 3 times 3, so the 2 3's in, send 1 3 out, and the 5 is left over inside. Oops. So now, can we just leave it that way? No, we can't leave a root in the bottom. That's what they're saying, rationalize the denominator, get the root out of the bottom. So how do we do that? We just multiply top and bottom by the root of 5. And what do we get? Root of 35x, because 7x times 5. On the bottom, the 3, and then what's root 5 root 5? Well, it's root 25, which is what? Plane 5. Or even quicker, remember, whenever you have two of the same thing in a root, it sends one outside, one plane. So root 5 makes plane 5. So what would that be then? Root of 35x over 15, right? Because 3 times 5 is 15. And that's it. That's as far as we go. We can't simplify that because this 15 and this root 35 are different worlds. One's in a root, one's out of a root. So there's no interacting. They just stay separate. And there it is. Okay, so number 15, same kind of thing. We got to get rationalized denominator, which means get rid of the root from the denominator. The difference on this one is that we not only have a root, but we also have a plus or minus. See, look back at the last one. We had a root on the bottom, but we didn't have a plus or minus. Nothing was added. Even here, it was 3 times the root of 5. It wasn't 3 plus the root of 5. So when you have adding, subtracting, let me write a little note here. When square root and plus or minus in denominator multiply top and bottom by what's called the conjugate, which means, what is the conjugate? It's the denominator with opposite sign in the middle. So I'm going to multiply by 1 minus root 7 on the top and the bottom. Like that. Let's go to a fresh screen here. So number 15, 7 over 1 plus root 7, multiply top and bottom by 1 minus root 7. Like that. Okay, and then this 7 is going to go boom, boom, and distribute. 7 minus 7 root 7 over. And on the bottom, this guy will go to both. 1 minus root 7, and this guy will go to both. Plus root 7, and then minus plane 7. Did you see that? Root 7 made plane 7. Positive times negative made negative. And root 7, which is root 49, makes plane 7. Or you could just say root 7, plane 7, right? Because 2 7's in a root, 2 7's in a root, 1 7 out of the root. Okay, so what happens from here? Well, these guys cancel. That's the whole reason the conjugate works. That's why we use the opposite sign, right? If this is plus, we use minus top and bottom. Why? So we get 1 minus and 1 plus in the roots, and they go away on the bottom. That's why that works. So we get 7 minus 7 root 7 over what? What's left on the bottom? 1 minus 7, which is 7 minus 7 root 7 over negative 6. There we go. What did we accomplish? We got rid of the root on the bottom. No more root on the bottom.